the moon so close to the Earth? Is this a figment of our imagination or something out of a sci-fi novel? Neither really. Countless years ago, during the evolution of the moon and the Earth, the moon was in fact this close to us. Over the years, due to tidal forces, the moon started receding at the rate of 3.8 centimeters every year. Today, at 384,000 kilometers away from the Earth, it is still the celestial object closest to us.
No one is certain how this charcoal black and snow white celestial companion of Earth was formed. The most likely theory is that a Mars-sized planetary body, traveling at high speed, collided with the young Earth. The molten material from the two bodies eventually formed the Moon. With relatively less gravitational force, and due to lack of atmosphere, the Moon's surface has changed very little, preserving in itself the history of planetary evolution. Fascinated by many such facts about the Moon, humankind dreamt of reaching the Moon someday. This dream became a reality in the middle of the 20th century. In the 1970s, however, the focus shifted from our Moon, and other planets and their moons became the target of space missions. The interest in exploring the Moon was reignited in the 1990s when the space probes found evidence of what appeared to be signs of water ice, hidden in shadowed craters in the Moon's polar regions. This initiated a renaissance in lunar exploration, of which Chandrayaan-1, India's first mission to Moon, is also an essential part. The Chandrayaan-1 mission will fulfill the Indian dream of reaching the Moon. It is India's first mission to venture out beyond Earth's orbit and travel into deep space. Chandrayaan-1 spacecraft is cuboid in shape, of approximately 1.5 meter size, weighing about 1,400 kilograms at launch, and will have a mass of 590 kilograms in lunar orbit. A 3-axis stabilized spacecraft, its orientation control and high stability is ensured by its electronic brain, with the help of sun and star sensors, gyros, reaction wheels and propulsion system. Chandrayaan-1 spacecraft propulsion system uses monomethyl hydrazine as fuel and mixed oxides of nitrogen as the oxidizer. Liquid apogee motor and thrusters are an essential part of the system. A single canted solar panel will generate a maximum of 700 watts of electrical power. During the eclipse period, the spacecraft will be powered by lithium-ion battery. ISRO Satellite Center, ISRO's lead center for developing spacecraft technology, has designed and developed Chandrayaan-1.
The Chandrayaan-1 spacecraft carries 11 scientific instruments or payloads developed by the Indian Space Research Organization, the Physical Research Laboratory, and other scientific institutions from across the world.
Of the 11 payloads, 5 are indigenously developed in India. Terrain Mapping Camera, TMC, and Hyperspectral Imager, HiSi, developed by Space Application Center, ISRO, Ahmedabad. High Energy X-ray Spectrometer, HEX, developed by Physical Research Laboratory, Ahmedabad, and ISRO Satellite Center, ISAC, ISRO, Bangalore. Lunar Laser Ranging Instrument, LLRI, developed by Laboratory for Electro-Optic Systems, LEOS, ISRO, Bangalore. Moon Impact Probe, MIP, developed by Vikram Sarabhai Space Center, ISRO, Thiruvananthapuram.
As part of international cooperation and an exchange of ideas, information and knowledge, ISRO announced an opportunity to all scientific institutions to fly instruments on Chandrayaan-1. Of the many proposals received, 6 were selected on the basis of scientific merit in meeting with mission objectives of Chandrayaan-1. Of these, 3 were from the European Space Agency ESA, 2 from American NASA, and 1 from Bulgaria.
The ESA payloads on board Chandrayaan-1 are Chandrayaan-1 Imaging X-ray Spectrometer, 6, is jointly built by Rutherford Appleton Laboratory, UK, and ISRO Satellite Center, ISRO. Smart Near-Infrared Spectrometer, SIR-2, is developed by Max Planck Institute for Solar System Science, Germany. Sub-kilovolt Atom Reflecting Analyzer, SARA, is a collaborative venture between Swedish Institute of Space Physics, Sweden, and Space Physics Laboratory, Vikram Sarabhai Space Center, ISRO. NASA-facilitated payloads are Mini Synthetic Aperture Radar, Mini-SAR, from Applied Physics Laboratory, Johns Hopkins University. Moon Mineralogy Mapper, M3, from Brown University and Jet Propulsion Laboratory. Radiation Dose Monitor, Radon, is the 6th payload from abroad being accommodated on Chandrayaan-1. Chandrayaan-1, with the support of all its 11 onboard payloads, will systematically map the entire lunar surface, investigate the moon's mineral and chemical composition, detect water ice, if any, on the lunar surface, and through all this, look for clues on the origin and evolution of Moon.